Laboratory preparation of chlorine gas. The first method is the oxidation of hydrochloric acid. The commonly used oxidizing agents include potassium manganate 7, manganese 4 oxide, lead 4 oxide, potassium dichromate 6. The second method of preparing chlorine is the reaction of an acid with calcium hypochlorite, or commonly called bleaching powder. Calcium hypochlorite is written as CaOCl2. The first method is the oxidation of concentrated hydrochloric acid using a strong oxidizing agent like the ones we have mentioned before. The setup is arranged according to the following diagram, as you can see here. When concentrated hydrochloric acid is delivered dropwise to a strong oxidizing agent, for example, potassium dichromate 6 or lead 4 oxide, and the others that we have mentioned, chlorine gas is liberated. The gas is first passed through water or sodium hydrogen carbonate solution in order to remove the acid spray or the hydrochloric acid fumes from the gas. Then secondly, it is passed through concentrated sulfuric 6 acid to dry the gas. It is collected by downward delivery because it is denser than air. In order to know if the gas jar is full, we could easily put a moist blue litmus paper on the gas jar and once it turns red and then it is bleached, we will be sure that the gas jar is full of chlorine gas. Now let us look at the equations for the reactions that takes place in the round bottomed flask. Now if we use manganese 4 oxide, the reaction is as follows. Manganese 4 oxide reacts with concentrated hydrochloric acid to give us manganese 2 chloride, water, and chlorine gas is liberated. Secondly, when potassium manganate 7 is used, it reacts with concentrated hydrochloric acid to give 2 salts, one which is potassium chloride and manganese 2 chloride, some water and chlorine gas. When lead 4 oxide is used, we will have lead chloride, water, and chlorine gas. As you can see, there is sort of a pattern forming already. Finally, when potassium dichromate 6 is used, it reacts with concentrated hydrochloric acid to give potassium chloride, chromium 3 chloride, water, and chlorine gas. In all these equations, you'll notice that the metals or the cations that are on the reactant side form chlorides on the product side. For example, in the first equation, manganese forms manganese chloride. In the second equation, potassium forms potassium chloride, while manganese forms manganese 2 chloride. The rest are just the same. So in general, we can say that an oxidizing agent reacting with concentrated hydrochloric acid would give us a metal chloride water and chlorine gas. This will be easy for you to remember. So in case you're using any of these oxidizing agents, the only difference would be to balance the equation. The second method of preparing chlorine gas is the action of dilute mineral acid on calcium hypochlorite. A mineral acid is the ones that are manufactured, such as hydrochloric acid, sulfuric 6 acid, and the others. The setup looks like this. Dilute hydrochloric acid or another mineral acid is delivered dropwise into bleaching powder, which is calcium hypochlorite. The reaction that takes place liberates chlorine gas, and it is collected by downward delivery. Now, just as in the previous methods of preparing chlorine gas, this gas can be dried by passing it through concentrated sulfuric 6 acid. For the equation, calcium hypochlorite reacts with dilute hydrochloric acid to form calcium chloride, water, and chlorine is liberated. If another acid such as dilute hydrochloric acid was used, a similar equation would be calcium hypochlorite reacting with dilute sulfuric 6 acid to give us calcium sulfate and water and chlorine gas. So, in order to balance this equation, we would just check it out and see. Calcium is 1, calcium is 1, oxygen on the reactant side are 5, on the product side are 5, chlorine on the reactant side are 2, chlorine on the reactant side are 2, hydrogen on the reactant side is 2, hydrogen is 2 on the product side, sulfur is 1, sulfur is 1, so the equation is balanced.